Hello and welcome back to another festive coding session with Mr. Jacob. We are still in our Advent of Languages, day 10 to be precise. In the Advent of Languages here on this channel, we strive to implement the same thing every day in a different language. And what we are currently trying to implement is more or less an ASCII representation of this same old Christmas tree over and over again, but with different twists and specifics to each of the languages that we use. And today, the language is TypeScript. And as we have done JavaScript already, and TypeScript is only a superset of JavaScript, we could actually run our JavaScript code just within TypeScript and everything would work out. So I decided to do this with a twist, to simply create this Christmas tree within TypeScript's type system, so that we actually get a warning during compile time should we supply the wrong structure of the tree. So to speak, we are creating a type that will validate the output structure of our tree against or with the TypeScript compiler, which is a little bit tricky and a little bit complex, but I guess we will get this to work. So what I have prepared here is actually only a simple runtime kind of, where we have our hello Xmas TS file, which we will create in a second. And then we have all the needed dependencies here like TypeScript and TSX to actually run this file, to live compile it with TypeScript, to check its types and to run it then. And that is actually exactly what we want. So let's quickly touch the hello Xmas TS file here and let's go over to our here Visual Studio Code, and there we can now open our hello Xmas TS. And as you can see, we can get right to it. Before we can actually get going, we need something that we are in the end going to compare our type against. So let's do something like tree, and we want the array type here. And as you can see, we have those nice little inline hints, which currently show us what the TypeScript compiler infers for any variable that will actually help us developing our typing system here. So what I want to do is actually, I want to go into our default README here quickly and take out this tree and just use it as a kind of, a starting point there. So let me quickly add that there and let me fix it up here. Let me remove all unnecessary starting spaces. Let me quickly make this an array actually by starting each line here at the beginning and then having each line here end. Let me see, after after it is finished, sort of. So now why doesn't this work? It doesn't work because of course we now need to escape our backslashes here, and I want those thingies here for now to be simply removed, those ornament thingies. And now we actually have a string array here containing our Christmas tree. And if we do simply something like console log tree here and execute this actually with an npm start, so using everything here. Oh no, that's not what I wanted to do. Yeah, of course, getting the array dumped here, but what I wanted to actually do was I wanted to come on, join this array with new lines so that we can actually have this a little nicer, like a string representation. And there is our Christmas tree. So that is not what we wanted to do here. The target here is not to display it in a console, otherwise we would kind of be finished even though we hard-coded it. But what we want to now implement is a way to tell the TypeScript compiler here that this tree is of type tree or Xmas tree or something like that. And the TypeScript compiler then should complain if something in this tree structure here, in this ASCII structure, it does not confer to this type. So let me for now remove that again, and let's start writing this typing here. So what we need first for this is a little bit of utility typing. So let me make this maybe a little bit bigger so that you can see a little bit better. First of all, we need a way to be able to calculate with numbers in types. So we need to do something like we need to subtract numbers from each other, to add numbers to each other, to multiply numbers with each other, because we need to somehow calculate all of this spacing. And as you remember, we need some sort of iteration for that. We can do that recursively with TypeScript types, but we need a way to calculate with numbers, to actually have processing numbers and being able to do something like -1, +1, times n, and stuff like that. And you cannot do that directly in TypeScript types, but there is a neat trick to do that by using an array of type elements that have the same number as the number you are requesting. So what we first need is we need something we call build tuple. And build tuple takes a number. So we take simply a number in here, and we have some sort of accumulator, which actually extends an array of n of the type any. And we start this one up with simply an empty array. So that is actually the type, the generic type that we now want to implement here. So what we are now going to do is we are telling our type system here that if the accumulator, as we specified it, is an array, it has definitely a length. So if this accumulator's length extends the number n, so it is a specific type like this number n, then we actually simply return the accumulator, because then we are finished. Otherwise, we call recursively, or we recursively return this tuple type and specify still the number n. We simply pass that through, as well as the accumulator. However, we now add something to the accumulator. So we put every element in there that is already in there, plus we put another any element in there. So we can actually put a type in there. We are just building an array of types because we are in the type system. We are not in any JavaScript context here. We are in the type system there. So what we now have is, if we do something like type foo, which is of, or could be something like build tuple, for example, 3, then what we would get here, let me quickly show you, is something like, this. So now, if we do a build tuple 3, we get actually a type tuple which has these 3 any types in it. And if I do, for example, 4, we get 4. Or if I do 2, we get 2. If I do 0, we get an empty thing. And so on and so on. So we now have a way to convert numbers into a tuple of types, and we can actually kind of work with those tuples in TypeScript. So what we first now do is we create ourselves a subtract type, which allows us to subtract things, numbers from each other. So let's create a type called subtract, and it takes a number a, which is a number, and a number b, which is a number. And now we tell the system that this subtract type is actually an we will see in a second where this goes. We actually tell it that we want to, build a tuple of a. So now we actually have the number of tuples in a there. So the starting point where we want to actually subtract something from. And we tell the system that this one should extend an array, because now it is an array of any, and this should extend an array where we actually have all of the tuple values, or the tuple count kind of b in. So this array contains of all the tuples of b, so the number of tuples of b, and we do an infer rest or result, or we could simply call it R, because it is our result here, and this is the rest of the elements. So what we essentially now told TypeScript is that we want it to take a look at build tuple A, so this tuple array with the count in there, and to match it against the count of tuple B in front here and with the rest of R, which essentially means that we now have the rest which is there if we subtract the amount of B from A in this R. So the only thing that we now need to do is, if this actually here is the case, we need to simply return the length of R, because now we have a number there, and otherwise we simply, and the question mark should be there for formatting reasons, otherwise we return the never type, because then something happened that made this impossible. For example, that the tuple B was bigger than the tuple A, then nothing fit actually in there. Okay, so we can test this as well. We can say type foo equals subtract I don't know, 23,3. So this should actually be now 20, shouldn't it? And we ask the system, and it tells us type foo is 20. So this actually works. Great. So now we need another type. We need the add type. So let's create an A extends number. B extends number. And this one kind of works similarly, only that we now need to add the things here together. So we are simply taking all elements from build tuple with a number A, and we join that together in an array with build tuple from number B. And now we actually already have our array here. However, we need to kind of check that this actually extends an array, any array here, because we need to make sure that this creation here actually worked, because you could have put negative numbers in there or something like that. So TypeScript knows that, and TypeScript assumes therefore that it could actually happen that this type does not match. So we need to ensure that it is matching in order to use it later on as a guaranteed result set, so to speak. So actually we can now check that this extends any, and if it does, we would like to return, of course, the length of this. So what we could do here is now we could actually say, okay, if this is any, then we want this here, and we want the length of that. Or we simply return never as well, because then something wasn't right there. So as we are going to do this here, this doesn't look good because we actually duplicated that. We can, so to speak, do something like and say it should expand a type R, which is our result again, and we want this type to be inferred by TypeScript, please. And so what happens is that this thing here will now be, or this R will be inferred to extend this here, which means it will be this in this case. And then we're checking that this extends any, so we can actually now simply put the R here, which makes things a little bit more easy to read if you are in the habit of reading and writing those types. So let's see if this actually worked out as we wanted to. So let's see, type foo should be add 2342. And now what is actually the result of this? Let's see. This foo type is now we did actually a little bit of an error here, because of course we don't need the array with all the any's in there, but we need actually the result of this as a length. So we are taking the R of our length, and as you can see now here we have 65 as a result, which is actually correct. So now we have our ways of calculating stuff. So what we of course now need is we have all those repeated spaces here, or we have those repeated minus signs here. So we need a type to actually check a repetition of a certain string. So that is the next thing that we will be building, repeated string. So this repeated string thingy here will take an S, which is an extends string. So it will the string to be repeated there. It will take an N, which is the number that it is repeated by actually. And we will need some sort of accumulator again to store the string that we are actually kind of creating there. So the accumulator in this case extends a string, and it starts simply empty. And now let's see how we can actually define this thing. Maybe we should put this into more than one line so that is a little bit more readable, I hope at least. Okay, so how will we actually define this? Of course, it will be recursive again, but we need to start somewhere. So we can actually check the length of a string, can't we? So we can actually tell or ask the system if ACK length extends. I need to, of course, make it like this. If ACK length extends n. At least you could think that we can do it this way. However, unfortunately, we really can't, because this is not going to work. We need build tuple around those. So every time we check those against each other, we need to check types against each other, not numbers, because tuple. Because as you remember, we can't really calculate with numbers. We can't really put them together. We only can do this with types. That's why we are creating these types arrays recursively. So if actually the length of our created accumulator is n, then we are finished here, and we can simply return the type of our accumulator, because now we have all that in our string. However, if we are not having this type already, then we need to kind of add another one recursively, another part. And you can use template strings in TypeScript within the type syntax, within the type system, to define strings with types in it. So what we can actually do here is we can say the system that we now want to return another repeated string type here, so a recursive call actually, with, of course, the string to extend there and the number to extend there, but we are now adding something to the accumulator. So what we are doing here is we are telling the system, get me the string that is currently in accumulator, and I want to add something to it. And what do I want to add something to it? I want to add s to it. And so now we have a recursive call here, which goes simply ahead and adds to this accumulator all of the time until it is properly filled up. And then this will be returned as a type. So let's see if this works as we intend it to be. So repeated string, let's, for example, take the dot or something like that. And let's say we want that 4 times. And I think we did something wrong here, because it is complaining. The type instantiation is excessively deep and possibly infinite. Okay, this means that it is not sure about if this would actually be an endless recursion. So what did we actually do wrong there? Okay, I'm not 100% sure actually where's the problem there, but we can simply do this another way that should work then. We can actually add another thing here that we, for example, call counter, and the counter is a number and it starts with being n. So that's the usual way you would do this. You would actually handle this stuff if something like this happens. And what we now do is we are not checking that the length actually is the build tuple. We are checking that build tuple of counter actually does extend the empty array. So if this is the case, then the counter thingy here reached 0, so to speak. And if this is the case, we return the accumulator, and otherwise we will simply do the same thing as before. However, we will use our subtract type that we created before and simply subtract 1 from our counter here, which now should actually work. And as we can see, there is no error anymore, and at least as I hope, this should now be type foo exactly with 4 dots. And as we can see, those are not 4 dots because it doesn't know what is in there, but it is actually the amount and the string. So it now is capable of telling us that this type here, repeated string X, is actually 5 X's. We created a type within our type system that can repeat a certain string. So now we have everything there prepared to start creating really our tree. So what we now first need to do is we need to somehow create the construct of each of those groups here, as we do always. So this group, and this group. So what we are going to do here, we are defining a type that is called tree group. And this tree group takes, as all our usual functions take, the n here, which extends a number that defines which of the tree groups it is, started at 0, going to the maximum amount, and len, which is actually the maximum amount of groups that will be reached, which we need to calculate those spacings here. So this will be a number as well. And so we create this tree group here, and what we need here, of course, is some sort of accumulator again, because we need to recursively do this, as we can see, as it is kind of or do we? No, we don't. No. We are only creating one single tree group, aren't we? So we don't need an accumulator there, but we will need that when we are kind of looping tree groups in a second. Okay, so what actually would be our tree group? Our tree group would be an array. And it would be an array containing strings. So it would be an array containing, and we can again use the template strings using in combination with TypeScript types. So we can only use types there, but this should actually now work because we have now repeated string, and we can tell it that we want repeated string of a space, or let's maybe do an X here for now, just to have it a little bit more visual there. We want a repeated string here, and of course we need to put that into the typing expression here. So we want a repeated string with X's, and the amount that we want would actually be the full number of iterations that we need minus the current n. So what we do here is we simply tell it that we want here subtract len, n. And this now gives us the spacing. Then a slash should follow. Then again, we want a type there, which is a repeated string that is, let's say, an A, for example, for now. We will change that to spaces later, but so we can more easily debug that should a problem arise. And we want that, in this case, the spacing between our tree here, this one here, for example, is the level we are in times 2. So this would be multiply. Did we actually write a multiply? I don't think we did. So maybe we need to do that. Multiply, and that would be n times 2. And yeah, as I've thought, we haven't implemented multiply. So let's do that in a second. Let's finish this quickly up here. This should be a backslash at the end, because that's the part of our tree here at the end, and we simply put that there. Then we do this 2 times because each of those groups has 2 segments, and in the second segment actually we are subtracting one more here. So what we could do is another subtract around that. And we are putting 1 here because now we need to move 1 further to the left. Okay, and the inside is actually the n plus 1 times 2, which we need here in things of spacing. So what we do here is simply we wrap this this n in an add, where we add n and 1. So now we have that. And actually, we could use that if we had a multiply, which we didn't implement, obviously. So let's quickly implement a multiply here. So a multiply would be an A, which extends a number, and B, which extends a number. And it would actually need some sort of accumulator as well. So what would we actually accumulate there? We would accumulate there is the result. So the accumulator would extend an any array, and it would actually, let's see, start empty. Yes. Okay. So how would we actually implement that? We kind of need to take number A and add it up with itself in the accumulator for each time this number B exists, kind of. So what we could do is something like if B, if build tuple, because we always need to only compare types. If build tuple B extends the empty array, then we don't have iteration cycles kind of anymore. So in this case, we simply return the accumulator here. If B has still something left, we are doing a recursive multiply here. So we are returning multiply with the same A value as before. We are actually subtracting 1 from B, so we are going down there until it is actually 0, and we are adding to the accumulator, or we are kind of adding to the accumulator one further amount of A, so to speak, and we need, of course, put the already accumulated things here in front. So this should actually, wait, there's a bracket missing. This should actually implement our multiply type. Let's quickly check that it really does. So type foo would be multiply, I don't know, 3 by 4, for example. And now if we check what this type here is, actually, it should be, oh, and there you can see I have forgotten to do a length here, and now this should be 12. Okay, perfect. So now we have a multiply type implemented. As you can see, it works exactly the same as the add or the subtract, only combined with a little bit of recursion. So what's its problem here? Type build tuple and so length does not satisfy the constraint number. Okay, we forgot to make sure actually that this is really a proper number, because it could happen that this isn't if we have wrong input typing. So what we need to do essentially here is we can do something like if this extends number, that is, I guess, the easiest way to do that. Then I want to return accumulator length, and otherwise I would return never. And let's just put that there. And yeah, so if actually we have this case which happens, we are still again checking if this really is and satisfies number, and now you can see that this actually works. So what now does this type tree group be? So if I do type foo is a tree group of, let's say, 0, so 0, 3, for example, which would be the 0th tree group in a count of 3 tree groups. What would this actually be, speaking type-wise? And now we are already getting there where we want. So now, as we can see, we now have actually an array with the 2 entries of the first tree group. So we have 3 spaces, which is correct. Those are those spaces, then a slash, then 2 backslashes, then 2 spaces, then a slash, then 2, and so on and so forth. So this is already working quite nicely. So what we need now is we need a recursive iteration over those tree groups. So something like tree groups, for example, and we want tree groups with a certain len. So we want a specific len of tree groups, a specific amount. So let's take that there and let's get that ready. And we need, of course, an accumulator again, because we are accumulating things and we can only do this recursively in TypeScript types. So what we are doing now here is we are always the same thing, saying this one extends. However, this one extends a string array, because we are essentially collecting all of those string parts of the tree. So this accumulator is a string array, and it extends and starts with an empty array. Furthermore, what we need is a sort of counter here, because again, we need to count down from our len to iterate through all of that, to kind of recursively do a loop there. So this one extends number as well, and this one starts being the len. So let's see, can we format this maybe a little bit different here? That would actually be nice. Something like this. Okay, so now that we have that, why is it complaining about that? Because I somehow removed number there. So len is a number, and now this looks all fine again. Okay, so now we need to kind of iterate again. So what we can do here is we say, as always, come on, create. Not create. How did I call that? Build tuple. Exactly. Build tuple. Counter. Sorry for that. If this extends the empty array, we are actually at the end, we are finished. So we are kind of simply returning the accumulator here, which is the array that we are looking for. And otherwise, we are actually going ahead and recursively using our tree groups type with the len. We are subtracting actually from the counter simply 1 so that we can count down until we are finished. And in our accumulator, we are going to do the following. We are putting everything in that already is in the accumulator, plus we are putting in the result of one of our tree groups. And to be precise, it will be we now need something like an I, like the iteration count. So what we put in there actually is the full length minus the counter, because we want to count up, not down. So that we can easily calculate now with subtract. We are doing the full length minus the current counter, which is kind of the indice that we are putting in there, and we are giving it the length there, as well as the tree group as we implemented it here needs the length to calculate all the contents there. So when we put all of that into this type recursively, we should already have now our tree groups ready. So let's see if this is actually the case. So if we have, no, not that, but that type, and we are nearly finished actually. So if this is tree groups, and we want tree groups of, let's say 3, then what would that actually be here? The foo now would be actually, as you can see, the combination of all of those different tree groups, which is already really nice. So we have done our iteration here as we need it. So now we can finally build up our type tree, or Xmas tree, let's call that. So our type Xmas tree now takes, of course, an n, which is a number which tells the system, or the tree, how many groups and levels we want, so that we can have this kind of in a dynamic way, because otherwise we wouldn't have needed to implement all of that stuff. So what we are doing now here is we are telling it that this will be an array actually. And this array will first of all contain all the tree groups that are actually having those len as well. So we are going to insert their tree groups for the level n. So those are all our tree groups. So this is actually this part of the tree, this whole part of the tree. Now what is missing is this divider part here and this trunk part here. So we can actually add that as well, because the divider is simply a repeated string, and it's a repeated string of minus characters, and it's a repeated string of minus characters with a certain amount, and the amount is actually the multiplication of the n times 2, and then we need to add to that another 2. And this is actually the minus signs there. And now only our trunk is missing there. And our trunk here actually can easily be created there. We simply call that tree trunk, and we give it the n as well, because it needs to know how many entries or how many groups there are to calculate how many times it needs to put a space there to put the trunk in the middle. And let's quickly define that here as well. So we do tree trunk n extends number. And this one is actually quite easy, because it will simply be an array containing template literal types. So we can do that again here. We can tell it that we want repeated string, and we want space repeated, and we want that n times, and then we want those, sorry, that were on the wrong place. Then we want those trunk characters there, so those pipe characters there, and we actually want that 2 times here in this array, and now we have defined that there. And actually now, if I now tell my system here that this is actually an Xmas tree of level 3, we are getting told that this is not working. However, what is quite interesting is we are getting told that only this top part is wrong, that this bottom part actually is quite right. And the reason for that is, if we look at that, is that we still have our placeholder characters in there. So if we now quickly go back to our, where is it? Our tree group creation here, tree group there, where we had this to better see where we're going, and replace those with spaces instead of X's, and here with spaces instead of A's, you can now see that we have kind of compile time checking of our tree, because now this is completely matching this. However, if I would add a space here where it does not belong, the system would automatically tell us that this string is not being able to be assigned to one with a space less, because it is expecting one that has a space less. Or if I would have done something like I would have done another one in here, it would tell us that, hey, wait a second, something's wrong here. I can't actually assign that here. You need to put some certain structure there. Or if I would now put an ornament in here, for example, it would tell me that this is the wrong position for that. This does not work. I could do one of those divider thingies less, and it would tell me that. So we have actually now implemented in our TypeScript type system the validation and the creation of such an Xmas tree. We now have an Xmas tree free type, and yeah, it looks kind of horrible if you really look at it, because that is not what you usually do with TypeScript. But I thought it might be really fun, and I'm quite sorry that this video is a lot longer than the other ones. However, I thought this would be a really nice thing to do, and I'm not sure if I could have done it a lot shorter here, without just showing you the correct code that is already there. However, then I guess maybe you wouldn't have even understood anything about that, because it then would have been too fast. I hope you had fun seeing me do this kind of special here, hacking together a TypeScript type which actually validates one of our Christmas tree structures. I at least had a lot of fun doing that, and I'm really happy that this worked out in the end, because I wasn't really sure that this was going to work. I kind of sketched this up beforehand, but I've never completely tried it. So I hope you had fun. I hope you join me in the next one, when there is the next installment of the Advent of Languages tomorrow, where we tackle another language. So see you then. Bye.